Hi guys! Today we are going to be starting a new section here. This is called conic sections. Please make sure you guys have these notes available on hand because I will be checking these tomorrow in class. Before we start on this, I want to just show you what this whole chapter is going to kind of be about. So it's called conic sections. You don't have this in your notes, so just take a second to look. What these are pairs of cones and showing different ways that they could be sliced. So these are sections of cones. So if a cone is sliced in this direction, we're going to get the shape of a parabola. If you slice a cone this way, kind of horizontally, you'll get a circle. If you kind of slant the slice, you'll get an ellipse. And then if you do a vertical slice and you hit both of those cones, we're going to get something called a hyperbola, where there's two curves. So this is what we're going to be doing over the next few lessons. All right, but back to these notes. Notice, these formulas do not look like the ones that you're probably used to working with. So they are a little bit different. You do have a few similarities from previous, where you have H and K. That will still be the vertex. But one thing I really want you to notice differently about these two formulas is that this one has x squared, where this formula has y squared. So if it's x squared, these are going to open up or they're going to open down, where a y squared is going to open either left or right. And I want to take a second and show you why this is true. So let me just get a graph out here real quick. So if it's x squared, like this one, it's going to open up or down, meaning that it could cross my x-axis twice. X squared. If it's a y squared, it opens left or right, meaning that it could cross the y-axis twice. Now, of course, I know these could be shifted and not really cross the x or the y-axis, but think of it that way when you're trying to remember the difference between those. X squared could cross the x-axis twice, y squared could cross the y-axis twice. So a way to kind of help you remember it. So when it says opens, when it's x squared, it's going to either open up or it's going to open down. Now, we talked before it opened up when a was positive. We don't have a here this time, but we have this p, and we'll talk about that in just a little bit. But when p is greater than 0, or when p is positive, it's going to open up. And when p is less than 0, or when p is negative, it's going to open down. Similarly, over here, this is going to open either right or it's going to open left. So it's going to open right when p is greater than 0, or when p is positive, and it's going to open left when p is less than 0, or when p is negative. And you can think of it like this. Here is it opening to the right. That's where my, it's opening towards positive values. Here it's opening left towards negative, I guess you could even say x values, because the p is touching the x. Over here it opens up when that p is positive, when the y values are positive, and it opens down when the y values are negative. So, or just remember positive up, positive right. Okay, parabolas. Every point is equidistant from something called the focus and the directrix. And I'll show you what those mean in just a minute here. The vertex, hopefully you guys remember what the vertex is. The vertex is just the point where the parabola begins. Or, it's HK here. I wrote K there. Okay, there, I whited it out. So it's the point HK. So the vertex, just like it was before. If you look up here, notice how the H has a negative sign in the formula, so it's really the opposite of what you see. Maybe make a note. It's the opposite of what it looks like. Yeah, it's the opposite of what it looks like in the formula, HK. Focus. This is actually kind of easier to see if you have a parabola. So let me just draw a parabola here. The focus is going to be, here let me also put, here's my vertex. We know the vertex is the min or the max. The focus is a point that lies inside the parabola. So maybe right there. Where the directrix is a line that lies outside the parabola. And maybe right there. So the focus and the directrix are the same distance away from the vertex. That distance is actually going to be that p, that variable that I said we'd talk about, or that constant, that variable, I can't talk. P is the distance from the vertex to the focus, or from the vertex to the directrix. So this is P distance, this is P distance. It's how far away it is. All right, now that we've kind of talked about all the parts of this, let's go ahead and try a couple examples. We're going to start by graphing these, and then I'll give you a graph and you have to write an equation. So example 1 says graph the parabola. So we need to find a few things first. First I need to figure out, is this going to open up or down, or is it going to open left or right? So it's y squared. Remember, y squared means that it could cross the y-axis twice. So if you need to, just look at a graph. If it's going to cross the y-axis twice, it's going to have to do this kind of a shape where it's going either left or right. Now, to tell if it's going to go left or right, I need to look at P to see if it's going to be positive or negative. Now, this is not P. If you look back at the formula, the number that's in front of the non-squared variable, x or y, is 4 times P. So here, this is really 16. So if I do 4P is equal to 16, and most of you guys can probably do this in your head, we know that P is equal to 4, because we would divide by 4. P is positive, so that means that it's going to open to the right. And again, I know it's to the right because it could cross the y-axis twice, so it's going to go in this direction. The vertex is whatever is added to the x, or subtracted to the x, and whatever is with the y. There are no numbers there, so it's just going to be at the origin, at 0, 0. There's my vertex. The focus is inside the parabola, so I have this little sketch here. So if this is my vertex, P is going to be inside the parabola, which means I'm going to have to go to the right P spaces. So P is 4, so from here I'm going to count 1, 2, 3, 4. That's my focus. That's the ordered pair 4, 0. So there's the focus. Now the directrix is the opposite direction from my vertex. Remember, this one's my vertex right here. That's the vertex. The directrix is going to be the same distance that P, but in the opposite direction. So since I went 4 to the right, now I'm going to go 4 to the left. 1, 2, 3, 4. There's my directrix. That is the line x is equal to -4. Axis of symmetry, this is also something we've done back in the past. This is what cuts a parabola in half. So there, an axis of symmetry cuts a parabola in half, which means it's going to have to go through the vertex right here. It's kind of my orange line. So this right here is my axis of symmetry, where that green line was my directrix. That was that one right here. Since the axis of symmetry is always going to go through the vertex, that is a y equals line because it goes left and right. It is also one that's y squared. So it's y equals, look at the y value from your vertex at 0. So it's y equals 0. Now, I'm not going to be really picky on what this parabola looks like, so I don't care how wide or narrow it is right now. If you would like to pick more points, go for it, but for now we're just going to do a sketch of this and make sure it opens up in the right direction. There's our first parabola. Let's try another one. Now, notice this one has an x squared. X squared means that it could cross the x-axis twice, so it's either going to open up or it's going to open down. Now, this is not in my standard form that I want. I want it to look like one of these two formulas, which means I either want the x squared to be by itself or the y squared to be by itself. The x squared is not by itself, so I have to do a little bit of work. I'm going to subtract that y over. So this formula looks like this. 1 over 8 x squared equals -y. Now also notice that it still does not quite look like this because I don't have a number in front of the x squared. I have a number in front of the y. So I need to get rid of that 1/8. So I'm going to do that just by multiplying both sides by 8. If there was a third part to this, I'd multiply everything by 8. So my new equation looks like this. X squared is equal to negative 8y. If I look for p, I'm going to do 4p is equal to negative 8 divided by 4. P is negative 2. Remember, we said this one was either going to open up or down. Since p is negative, this is going to open down. And again, that's because p is negative. The vertex, again, I find that by looking to see what's either added or subtracted to x and y. There's nothing added to the x and nothing added to the y. So I found the vertex again is at the origin, so I'm going to put that right here. I know the focus is always inside the parabola, so since the parabola is going to be opening down and p is negative, I'm going to go down 2. It's going to be inside the parabola because this is going to open down. All right, that is the ordered pair, 0, negative 2. The directrix is going to be a line that is the same distance away from the vertex that the focus is. So this was 2, so I'm going to go 2 in the opposite direction. I made it green last time, I'll do it the same color. So my directrix is right here. Your parabola will never touch the directrix. If it does, then you mess something up. So this directrix is y is equal to 2. So that's that line right here. Again, the axis of symmetry is the line that cuts a parabola in half. It's going to go through the vertex. It's also going to go through the focus. That is the line x is equal to 0. And the only thing I need to do now is just graph that parabola. We said it was going to be opening down. Here is my vertex. So it's going to do something like this. And again, it may be wider or more narrow, but that's good for now. All right, let's try to write an equation.